All right, welcome back. Um, to, for this video, we're going to start section 11.2, which is all about probability. So 11.1, we talked about fundamental accounting principle and permutations and combinations, which is all ways to count how many possibilities there are. But now we're going to start to apply that to actual probability. So our EQ is what is the difference between experimental probability and theoretical probability. As a quick warm-up, we're just going to run through an ACT type question just to practice like the standardized test, especially the math type questions. So this is actually an example of an ACT practice question that I pulled off of just off of Google. Just searched ACT practice math question, but it says a car averages 27 miles per gallon if gas costs $4.04 per gallon. Which of the following is closest to how much the gas would cost for this car to travel 2,727 typical miles? Okay, so obviously with any multiple choice, we want to pull out the numbers. 27 miles a gallon, $4.04 a gallon, and our trip is 2,727 miles. There's a lot of ways to solve this. I'm going to go ahead and say we're going to figure out how many gallons of gas we need and then multiply that by the 404 per gallon. And that will give us the answer. To figure out how many gallons we need, we have to take that total mileage, which is 2,727, and divide by the miles per gallon that the car gets. So if I take 2727 divided by 27, we're going to end up getting 101, I think. So I need 101 gallons. And then if gas costs $4.04 per gallon, I'm going to take that times 404, not 401, 404. You get $408.04. So D is the correct answer there. Nothing to do with probability, just again, going to kind of throw in some multiple choice practice. So in this little spinner wheel, I've got 6 options, 1 through 6. The question is, how many 5s should we expect to get it in 6 spins? So if I spin this thing 6 times, how many times should I expect to get a 5? Now, there are 6 sections. They're all equally spaced. So it's reasonable to say I'm going to, maybe get each number once. But we're going to actually conduct this experiment. So I have to do this in a different window, but if I just click on this spinner, so I got a 1, 3, 5, so that's 1. Another 5, that's 2, that was 4 spins, 5 spins, and 6 spins. So out of 6 spins, we got 2 5s. 2 5s out of 6 spins. Okay, so we're going to use these numbers to define our probability of getting a 5. Okay, we're going to start with experimental probability, and experimental probability is just that. It's it's the numbers that come from an actual experiment that you conduct. Okay, so the experimental probability of an event, we use the letter P just to stand for probability. And then probability is always written as a fraction, at least to begin with. The numerator, or the top of the fraction, is how many times did the event occur that I'm looking for. Number of times the event occurred. And again, the event that I'm looking for is usually written in parentheses after the letter P. And then the denominator is how many trials did you, or how many times did you conduct the experiment. So in our situation, the probability of spinning a 5 was 2 out of 6, because we got 2 5s and we spun it 6 times. Now, there's a lot of things you can do with this. We can reduce the fraction to 1/3. If you type 1/3 in a calculator, that's 0.33. And then some people will even go and call this 33%. Now, it's not exactly 0.33, right? It's 0.33 repeating. And so technically, right, if I'm going to 33.3%, okay. For the most part, when we're talking probability, just because of the calculations we're going to do later on, we want to avoid this. We want to talk about fraction or decimal, mainly because when we do later calculations and later on in Chapter 11, combining probabilities is a lot easier if it's already in a decimal or a fraction. So 0 is the lowest a probability can be. That's something that can't occur. And a probability of 1 means something that's guaranteed to occur. Okay, but again, experimental probability are events that actually happened. Okay, so kind of a quick introduction to probability. So if I roll 2 die, how many times will I get a sum of 7 if I roll it 4 times? So again, I'm going to use the actual file. Let's do this simulation real quick. If I spin each of these oh boy, come on. Okay, so there's one spin. Well, let's not count that one because I think it's the same thing. So spin number 1, I got a 6. Spin number 2, I get a 9. Spin 3, I get another 9. And spin 4, I get a 4. So what was our experimental probability of rolling a 7? The probability that the sum was equal to 7 is 0 out of 4. That math is easy. That's just equal to 0. So that was our experimental probability. Again, is there a 0% chance that you get a 7? No, there's a decent chance you get a 7, but our experiment led to a probability of 0. Okay. At this time, here's what I want you to do. Real quick, pause the video. I want you to write down 5 numbers from 1 to 50. Okay. You cannot repeat them. Just pick any 5 numbers. It doesn't have to be in order from least to greatest. You can jump around. If you want all single digit numbers, that's fine. We're going to see if you're lucky and win the lottery, and just see how unlikely it is that you do win this lottery. So go ahead and pause, and we'll go from there. Okay. Now, assuming you've picked your 5 numbers, okay, what we're going to do is we're going to actually use the calculator to see if your numbers are correct. So in the calculator, there's a way that we can actually get the calculator to give us 5 random numbers. Let's go 10 just in case there's repeats. So the winning lottery numbers are 48, 46, 8, 26, and 21. If you got those 5 numbers, congrats, you won the lottery. Now, if you have any family members that play the Powerball, if you've ever seen someone do a scratch-off ticket, right, you're paying money to try and win, but the question is, what's the probability of winning? My experimental probability is the probability of me winning based on events that actually happened. And I'm guessing if you picked 5 numbers, your experimental probability of winning was 0 out of 1. You probably didn't have those 5 numbers, and you had 1 opportunity to do it. Okay. The other type of probability we want to talk about is theoretical. Okay. So experimental is an event that actually happened, but let's talk theoretically. What are your chances of winning the lottery? Or this lottery, at least. Okay, so the definition changes slightly with theoretical. The numerator is now the number of ways an event could happen, which is also referred to as the event space. And then the denominator is how many possible outcomes there are, which is pretty similar to the other type of probability. But the number of possible outcomes is often referred to as the sample space. Okay, so what we're going to do is we're going to figure out what is the probability that you just picked 48, 46, 8, 26, and 21 as the 5 winning lottery numbers. Okay, so the event space is how many ways could you have won the lottery? And really, there's only one way that you win that lottery, right? There's only one winning ticket, and it's the ticket that has these 5 numbers that are displayed on the calculator. The sample space is a much larger number because the sample space is how many different sets of 5 numbers could you have chosen. Okay, and this is where using what we learned about permutations and combinations, we can actually utilize that to figure out the sample space very quickly. The first question is, does the order matter? Does the order that you picked those numbers in matter? What I mean by that is, if you picked the right 5 numbers, but they weren't in this exact order, does that mean you lose? And the answer is no. Like, the order in which you pick the numbers doesn't matter. So that means I have a combination on my hands. Okay. How many numbers did you have to pick from? Well, it was from 1 to 50. So we have 50 numbers to choose from, and we have a combination of 5 of them. Okay. So like we know from the calculator, 50 math, go over to probability. There are 2,118,760. Okay, that's our sample space. So the probability that you win the lottery is 1 out of 2,118,760, which if you want, we could change that to a decimal. It's a very small decimal. Oh boy. So that's 0.00000471. Or if you really feel like being an optimist and changing it to a percentage, that is the percent chance you have of winning that lottery. In all likelihood, you didn't win, but that is the theoretical probability versus the experimental probability, which again is most likely 0 for each one of you. So to summarize, what is the difference between experimental and theoretical probability? Experimental is something that actually happened. Okay. Events that actually, gosh, my handwriting is terrible and I apologize. I think I spelled that right. And then theoretical is obviously it's event space over sample space. And theoretical probability, you do not actually have to conduct the experiment. So that'll wrap it up for this video. Thanks for stopping.